The average rate of change of a quantity over a given period of time can be found by dividing the change in that quantity over the change in time. For example, if a city grows by 10,000 people over a period of 10 years, the average rate of population growth is 1,000 people per year. In this way, we can think of the average rate of change of a quantity as being given by delta Q over delta T. This is the change in quantity over the change in time. This is related to the old formula delta y over delta x, which of course is the formula for slope. This formula is basically the same as the formula for slope, except the variables are different. Rather than having y and x, we have q and t. So rates of change in slope are in fact intimately connected. Suppose we want to calculate a rate of change at a given time rather than over a period of time. In other words, we want to find an instantaneous rate of change. Basically, we want the change in time to be 0. So what we can do is we're going to take the limit as delta t approaches 0, and when that happens, we're going to basically get something which is the same as this formula. The limit as delta x goes to 0 of delta y over delta x. Now this is basically the definition of the derivative. So an instantaneous rate of change, a rate of change that happens in a specific time rather than over a period of time, can be found using a derivative. Some questions ask us what the derivative of a given function represents. In general, derivative can always be interpreted as an instantaneous rate of change. If the derivative is the derivative of a quantity y with respect to another quantity x, this other quantity is usually time, then the derivative is the instantaneous rate of change of y with respect to x. If we're taking the derivative at a given x value, let's call it a, then the rate of change is taken at that given x value. The units of the rate of change are always the units of y over the units of x. So in example 1 here, we're trying to measure the effects of a blood pressure drug. We've got a function p of t which gives the blood pressure in millimeters of mercury of a patient as a function of the time measured in seconds after the drug has been taken. So the question is, what does p prime of 1 represent and what are its units? Well, it's a derivative, so it is an instantaneous rate of change of, now what's the dependent variable? What's the y here? The y is p, which is blood pressure, B-L-O-O-D, pressure, with respect to, now the x here is time. Now, what does the 1 represent? The 1 represents the number of seconds after the drug has been taken. So what I would say here is 1 second after the drug has been taken. So that's what this represents. It represents the instantaneous rate of change of blood pressure with respect to time 1 second after the drug has been taken. What are its units? Well, the units of blood pressure are millimeters of mercury. The units of time are seconds. So the units of this rate of change are millimeters of mercury per second.